Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your chapter number 9, that is virtual memory. In the last class we have studied the last topic, that is the garbage collection. Now the next topic of the today's class is the common memory related bugs in the C program. That is, what are the common bugs or what are the common memory related bugs that is related to the memory are available in the C programs. That is the common memory related bugs. So first of all, let's take a quick recap what we have covered in the last class, that is the garbage collection topic. So let's start with the garbage collection topic. I have started with the chapter number 9 in last class, that is continuation of chapter number 9, that is a virtual memory. The topic that we have covered in the last class is the garbage collection. That is how automatically garbage will be collected from the memory. That is how the automatic way the garbage, that is a dump area, that is unused area, is collected to a one place, that is a garbage collection. So first of all, we have studied that what is a garbage. Garbage means any dead object that is not in used. So non-live objects are known as the dead objects, that is known as the garbage. This is almost all the garbage collectors assume the following definition of the reachability. More formally, an object is live if and only if, that is the object, if I say object is live, that is if and only if it is referenced in a predefined variable known as the root, or it is referenced in a variable contained in a live object, and the non-live objects that are known as the garbage. So any non-used object, any dead objects is known as garbage in computer science. Now next is the graphs. The object and the references can be considered as a directed graph. In the last class we have studied also what is a directed graph and what is a root, what is a mediator that is used in the directed graph. So every object, every reference in a graph can be considered as a directed graph. The live objects of the graph are those graphs that reach from the root. So in a graph there is a root node, that is the upper node, and then there are sub parts that are known as the child node or the parent node. One is root node, then there is a parent node, then there is a child node. So different parts of the graph are known as the child, root and the parent. Now, and we also studied what are the roots of a computer or computation. These may be the static area, register, stack. Next question that arises is why garbage collect? That is why there is a need for the garbage collection. Now, why there is a need? First of all, there is a language requirement. So it is a requirement of the programming language, that is either C, C++ to collect the garbage, to distribute or to collect the garbage or the dump area and non-live objects, that is the dead objects, into a one place. Example, allocated objects may survive much longer than the method that created them. Next requirement is that problem requirement. It also the requirement of the problem to collect the garbage. Then next, why GC? GC means garbage collection is a software engineering issue. Then we also studied why software engineering garbage collection is a software engineering issue that is used for the garbage collection. That is SE, that is management of complexity in the large scale system. That is a software engineering. What are the tools available? That is modularity and the abstraction. Then relieve the programmers of bookkeeping details. That is in manual way we cannot collect the garbage, and we cannot destroy the garbage, dead objects and collect into the one place, but it is better to spend the time on the higher level details of the design and the implementation. That is, relieve the programmer or relieve the programmers of the bookkeeping detail. That is, the manual way is replaced by the automatic way that is placed or that is produced by the GC, that is your garbage collection. Then we have studied what are the major areas of the memory, that is the static area, runtime stack, heap. So these are the major areas of the memory. Then next is what is a cell and what is a liveness. Any data item in the heap is known as the cell. So any data item that is available in the root or in the graph is known as the cell, that is a data item in the heap. Cells are pointed to by pointers held in the registers, stack, global static memory or in other heap cells. Now what are the roots that is available for the graph? The roots may be registers, stack location, global static variable. A cell is known as live, that is a cell is known as the live cell if its address is held in a root or held by another live cell in the heap. Next, garbage. It is a collection of heap memory that cannot be accessed by the program, that is your garbage. As I told you, the dead objects are known as the garbage. Then we also studied about the garbage collection, that is the automatically management or the automatic management of dynamically allocated storage, that is your GC, garbage collection. Then next is your example of garbage. What are the examples of garbage? These are the examples. Then why garbage collection? Why we are using the garbage collection? This says today's program consumes storage freely and mismanage it. What are the mismanagement in the memory? That is a memory leak, dangling references, double free, misaligned addresses, null pointer differences, heap fragmentation, or poor use of the reference locality resulting in high cache miss rate or excessive demand paging. These are the mismanagement of the garbage collection. Then next point says explicit memory management breaks high level programming abstraction. So these are the requirements why we are using the garbage collection. Then GC and the programming languages, that is what is the garbage collection and how garbage collection is used with the programming languages. This says GC is not a language feature, that is not a language feature, that is garbage collection. It is a pragmatic concern for automatic and efficient heap management, that is it is a concern for the automatic heap management that is used for allocating and deallocating the memory at the runtime, that is allocating at the one place and then destroy the objects. Then next is your what are the cooperative languages that is used, that is Lisp, Scheme, Prolog, Smalltalk are the cooperating languages with the GC. Next is what are the uncooperative language that cannot cooperate is C and the C++. Then we also studied about the perfect garbage collector. What is meant by the perfect, or what are the qualities for a perfect garbage collector? That collects the cells quickly, that has an excellent spatial quality or locality, that manages the heap efficiently. So these are the various qualities. Then we say that it is a perfect garbage collector. So any garbage collector that have a following facility, that have a following features is known as the perfect garbage collector. Then we have studied about the GC techniques, that is what are the GC techniques that is available, that is the garbage collection techniques. So one of the technique is the reference counting. Next technique is tracing. Next is your generation or generational GC. So these are the three techniques that we have studied in the last class. One is your reference counting, one is your tracing, one is your generational GC. In reference counting, we have studied about that it simply counts the number of references to a cell. That is, it means the GC garbage collector simply counts the number of references. Then it requires the time and the space overhead. That is, it requires the more time and the more space overhead to store the count and the increment each time a reference is added. So every time a reference is added, it requires the space and the time overhead. Then it also requires the reference count for the files. We also studied about the smart pointer that is using the reference counting. Then we have also studied about the example of the reference counting. That is, what is the example of reference counting, how it is used in the computer system. This is the example. These are the nodes, these are the memory, there is a root, there is a root set, this is a root, there are various heap spaces, this is one of the heap space, next, 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 next. Then this is the example. Next says keeps count of number of references to each object. As I told you, it keeps the count of number, it keeps the level or counting the number of the references to the each object. Then it also updates the count in response to the operation. That it updates the count, that is, one time it is updated to another one, again it is updated to another one. That is, update the count in response to the operation. That is, what are the operations and how it is added to the operations. Then how it will update, or what are the operations that is used is initialize, increment, decrement. So these are the three operations that is generally used in the reference counting. That is, we can increment, we can initialize, and we can decrement the values. Then what are the limitations of the reference counting, and what are the advantage, and what is the advantage and what are the applications of the reference counting. So the limitations is that there is a more space required, or the space overhead is more high, and the time overhead is also more high. Then next limitation is that memory leakage when cycles in data. So there is a memory leakage or when the cycles in data. Then these are the limitations. Then next is an advantage. This is the advantage, that is incremental algorithm. That is, it is an incremental algorithm. In this we can also increment it the values. That is a incremental algorithm. Next, what are the applications of the reference counting? Means where we can use the reference counting algorithm. We can use the reference counting algorithm in the Unix, Java, pure functional languages, scripting languages like Python, Perl, etc. These are the languages that is using the Unix, that is using the reference counting. Then next is your garbage collection, that is used for detecting and reclaiming unreachable objects automatically. Soundness, safety, completeness. So these are the three main features of the garbage collection. That is, it is used for the detecting and reclaiming the unreachable objects automatically. It also provides a safety, completeness, soundness. Then reachability is an approximation. This is the program that is shows that this is an approximation. We also studied about this program. This is a C++ program that is using the pointer for accessing the pointer values. Then next is your strength, that is a reference counting strength. So these are the strength of the one of the algorithm, that is a reference counting. What are the strength? First of all, there is a incremental overhead. So one of the main strength is that it has an incremental overhead. Then relatively easy to implement, that is, it is very easy to implement the reference counting algorithm. Then can coexist with manual memory management. So as I told you, GC is a automatic way to manage the memory. So it can coexist, or it will exist, or it will use with the manual memory management also. So it can coexist with the manual memory management. Then spatial locality of reference is good. So these are the various techniques that we have various strength or the advantages that we have studied in the last class. That is, there is a spatial locality, it can exist, or it is easy to implement, it can reuse the free cells immediately. That is, if there is any free cell, if there is any free block, then it can use the free cells automatically or immediately. Then we also studied about the limitations. As I told you earlier also, if any topic has an advantage, then this has a, or that topic has a disadvantage also. So what are the disadvantages? First of all, there is a space overhead, that is more space is used. Then time overhead, more time is required to fulfill the efficiency. Then cyclic data structure may cause the leak values. Now what are the cycles? This is a memory leak cycle. Now, how this reference counting is achieved by using the smart pointer in C++. So use the smart pointer in the C++ to automatically avoid the limitations of the reference counting. This is the implementation of the smart pointer. This is how this smart pointer can be implemented. Then using the smart pointer, that is how to use the smart pointers. Then mark sweep garbage collection, that is how to use the mark sweep garbage collection. Each cell has a mark bit, that is every cell that is used has a mark bit. Garbage remains unreachable and undetected until heap is used up. So this is the next technology, that is the mark sweep garbage collection. So one of the technique that we have studied in the last class is the that technique is reference counting. Then we have studied about the mark sweep garbage collection. There are two phases in this that we have studied. One is marking phase, one is sweeping phase. Marking means mark the nodes so that that node will be fixed and that cannot be removed, and the else nodes, that is the unmarked node, are totally removed and swept up or swept out by using the sweep algorithm. So mark and sweep contains two algorithms or two parts or two functions. One is marking, one is sweeping. Marking is used for mark the cells, mark the nodes, and sweeping is used to sweep the nodes, that is remove the nodes. This is the mark phase or the mark function. This is the sweep function in a programming language. Then mark and the sweep example. This is the mark and sweep example that is used. This says after marking this becomes 1, A become 1, C become 1, F become 1. After sweeping, all the memories are deallocated, that is A is free, C is free, and F is free. Now what are the problems and solution that we have studied in while using the mark and sweep algorithm? This is the example that we have studied. This is the free unmarked cell that is destroyed using the mark sweep algorithm, mark sweep. Now what are the cost and what are the benefits of mark sweep? These are the cost and the benefit that we have studied. Then copying collector, next topic is here, copying collector. That is the next category, that is the next technique that is used, that is dividing the main heap into the free space, from space and the to space. That is a copying collector, that is copying the collector from one place to the next place. This is the algorithm that is used to copy linked list. This is the example of the to space and the free space that is used. Next is your copying collector trade-off. That what is the copying collector trade-off and what are the benefits and the limitations or the strength and the weaknesses of this approach, that is the garbage collector trade-off. Now these are the advantages, that is good, bad. What are the good advantages? The compacting is very easy, very low cell allocation overhead, twice the memory footprint. This is the limitation. Now next part or the next approach is, this is the last approach, that is a generation or generational garbage collection. Now what are the observations? Most cells that die in the young stage, that is these cells are die before their maturity phase arises. So generational garbage collection divides the heap into generation and the GC, the younger cells, more frequently. These are the observations. This is the example. Now what are the practical issues that is used, or what are the practical areas in which we can use the mark and sweep on any algorithm that is used for the garbage collection, that is GC. One is unpredictability, efficiency, incrementability, finalization, external costs. So that's all for yesterday's session. Now let's start with the new session, that is a today's session. this is the today's session, that is the today's class topic. Uh, the topic is the common memory related bugs in the C program. This is the next topic, or this is the today's class topic. As a name advice, common memory related bugs. That is the common bugs that is used, that is related to the memory in the C program. That is the common memory related bugs in the C program. So in simple terms, if I say the problems that are that any C programmer or any C program is facing with related to the memory are known as the memory related bugs in the C program. Now let's start with this topic, or let's start with the today's session, today's topic. Now this says managing and using virtual memory can be a difficult and error prone task for the C programmers. This says when we manage and when we use the virtual memory, that is a difficult and the error prone task. That is a difficult level and the error prone task for any C programmers. Memory related bugs are among the more frightening because they often manifest themselves at a difference. So these are the most critical errors that is that any programmer of C language is facing. Why they are critical? Because they are related to the memory. And why they are so critical? Because every program is stored in the memory. So if there is any error in the memory, so that can affect every C program. That's why it is or it is saying that it is a very critical error, it is a very crucial error. This says common the memory related errors or the bugs in the C program. So they are very crucial because they often manifest themselves at a distance in both time and the space requirement from the source of the bug. Writing the wrong data to the wrong location, that is whenever we write any data to the wrong location, and your program can run for hours before it finally fails in some distant part of the program. This says whenever we write the wrong data, or whenever we write the wrong data to the wrong location, that is in the wrong memory, in the wrong location, then your program can run for hours before it finally fails in some distance time. So that's the main, that's why this is a critical error. Why? The main thing is that that program will run for an hour, but at last there is no output. We conclude our discussion of virtual memory with the discussion of some of the memory related bugs. These are the examples, or these are the categories of the memory related bugs of any C program. So in simple terms, the memory related bugs of C program is that any program or any programmer of the C language is using the programming languages, or is using the memory related bugs, so that memory will be related with each other. Suppose best example is that I am writing the C program and I miss the one file of header file, that is stdio.h. My program never works. Why? Because it executes every time it will store the output in the memory, but as there is error in the memory, because there is error in the writing the program to the right location, that gives an error, and that does not give the exact output at the end, but it executes at once, twice, thrice, but at last there is no output. That's why it is very crucial error of the memory related bugs. Now let's see what are the types of bugs, or what are the bugs available for the memory related. That is, what are the types of bugs for the C program in the memory. The first bug that is used, or the first error that is used, is the deferencing bad pointer. That is, we can deference the bad pointer. We use the pointer for the C programming, or we use the pointer for the C++, that is deferencing, or that is the bad pointers. That is, the pointer that we are using is the bad one. This is, as we learned in section 7.2, there are large holes in the virtual address space of a process that are not mapped to any meaningful data. If we attempt to dereference a pointer into one of these holes, the operating system will terminate our program with the segmentation exception. So this says there is a difficulty in referencing a pointer whenever there is a bad pointer used, whenever there is a wrong address used. That is, if I'm using the address of next variable, another variable, and using the reference to the next variable means storing the output in the next value in the next location. So there is difficulty. Why difficulty? Because in that location the output is not stored, because the address is changed, so there is a difficulty in storing the addresses. Also, some areas of virtual memory are read-only. Attempting to write to one of these areas terminate the program with a protection exception. A common example of differencing a pointer or bad pointer is the classic scanf bug. So this is the bug of the best example for the dereferencing the bad pointer. What is the example? That is using the scanf. As I told you, if I'm not giving the standard file, that is stdio.h, that includes the scanf, that also a dereferencing bad pointer example. So this is a classic example of the scanf. Suppose we want to use scanf to read an integer from the stdin. As I told you, there is a header file, that is the stdin, that is the stdio, that is the standard input output into a variable. The correct way to do this is to pass scanf a format string and the address of the variable. That is the main thing is that the correct way is that to pass the scanf a format string and the address of the variable. This is the correct syntax. However, it is easy for the new C programmers to pass the content of the val instead of its address. In this case, the scanf will interpret the content of val1 and as an address and attempt to write a word at that location. In the best case, the program terminates immediately with an exception. Now, what is the error? This is the correct one. Why? We are storing. A scanf means, first of all, understand, there are two concepts, or there are two parts. One is printf. Printf means that is used for printing the values. One is scanf, that is used for storing the values in the memory. Both are used in the C program. So printf is used for printing and scanf is used for storing in the memory. So if I want to store in the memory, that can be accessed by using the ampersand operator. Why ampersand operator? As I told you, ampersand is used as an address operator, and so whereas the scanf operation is used for storing in the memory in the form of address. So it is better to use the ampersand in pretend to the or in before to the variable name. So val is a variable name, ampersand is a or symbol that is used for scanf, that is used for storing the output or storing the input or the output value or the variable values in the memory. That is the scanf. And why we are using the %d? This is the identifier that identifies that the variable is of integer type, that takes 2 bytes in the memory. So this is the best example, this is a good example, right example, that is scanf %d ampersand val, that is storing the output or storing the input or storing the values of the val variable into the memory, that is the integer type. But if I'm using val, only val, and I'm using scanf, there is no ampersand, so computer does not know where this data will be stored. So this gives an exception error. In the worst case, the content of val correspond to some valid read-write area of virtual memory, and we overwrite memory, usually with the disaster and baffling consequences much later. This says in some cases this lead to the result, but in mostly cases this gives an exception. Why? There is no ampersand that is used. Next is your reading uninitialized memory. So first point says the dereferencing the bad pointer, that is using the bad pointer using the bad scanf operations. Next is reading the uninitialized memory. That is also the memory related bugs in the C program. Now let's see with the help of PPTs, that is what is the common related bugs in C programming. Chapter number 9, that is the virtual memory, that is continued. Now first topic is finding and fixing the bugs, that is how to find and how to fix the bugs in the computer system. This says in order to create quality software, order to create means in order to handle or in order to manage the quality software, you need to find your bugs, you need to find your errors in the program by doing the testing, by doing the test cases, by doing the testing techniques, or by using the techniques, that is the testing. Next is user reports, that is the quality software is also maintained or find out the bugs by using the user reports. Then next part is that the best bugs are those that are always reproducible, that is the best bugs or the suitable bugs are those bugs that are always reproducible. Then what are the types of bugs that is available, that is the types of bugs, that is GOTA, LOVE-M. Now what are the types of bugs that is generally used for any C programming language, that is not related to the memory, that is not related to any disk, but these are the types of common bugs that is available in any C programming language. First is your compile time. What is the compile time bugs means? The bugs or the errors that is available at the compile time. Compile time means at the starting phase. That is what are the errors? That is syntax error. As I told you, whenever I cannot follow the rules and regulation of the programming language. Suppose I have an instruction that in C programming language the scanf is used with the ampersand. That is a syntax that ampersand is have to be used with the scanf. But if I am not using the ampersand with the scanf, that also gives an error, and that error is kind of the syntax error. Next, spelling error. If there is a spelling mistake, that is a spelling error, that is also a type of the bug. Then static type mismatch. That is a static type mismatch means there is a static of the type or there is a static type that is of mismatch type. The best example, as I told you, there is a mismatch in the address. Suppose I am using the %d and I am using the float. That is not correct. Why? For integer variable or integer variable on the integer value, I have to use or I supposed to use the %d, but I am using the %f for the integer. So that gives an error. Why? There is a mismatch of the data type and there is a mismatch of the type specifier, that is a static type mismatch, usually caught with the compiler. Caught means usually found with the compiler. Next bug is that, or the next error is that available at the design time, that is a float algorithm. As I told you, there are few concepts or there are few methods for designing any program. One is algorithm, one is pseudocode, one is English statement, one is data dictionary, one is writing the program. So algorithm is also a technique for showing the problem or for solving the problem. So this is one of the technique that is also a category of the design technique, and bugs are also available in the design technique, that is a type of the bug. That is a float algorithm. Float algorithm means how the algorithm will be flowed. That gives the incorrect outputs. Next is your program logic. Next bug or the next type of bug that is available is the program logic. The next bug that is available is the program logic, that there is a bug or there is an error in the program logic only. What is the error? There is an error in the if else. I'm using the wrong syntax, I'm using the wrong usage of the if else. That is, if I'm using the if, there is no curly braces. If I'm using the else, there is no curly braces and there is no semicolon. As I told you, there is a syntax of the if else, that is if condition, that is if condition is true, then statement 1 will be executed, else statement 2 will be executed. So if there is a error in the if else statement, that is a program logic error, and that is also a type of the bug in many C programming language. Then next is your loop termination. That is the best example that mostly programmer, even I sometimes uses this error. That is loop termination. I terminate the loop but my output is not correct. That is a loop termination. That is close the curly braces of the block that is using the looping. That is a loop termination. Next, select case. So this is the also the program logic error, that is there is a select case error, that is if I'm using the select statement, then case 1 is missing, case 2 is missing. I'm writing, or if I'm writing case, then does not assign the value of the case and there is no default value. That is also error of the program logic. That also gives the incorrect output. Next type of bug, next type of error is the memory nonsense error. Memory nonsense error is that I'm using the wrong output or the wrong input. That is the best example is that I'm using the null pointers, array bounds. Array bounds means array is bounded, that is if I'm using 5, then I'm accessing the values of the 6. That is the array bound. Null pointers, bad types. Bad types means I'm using the bad integer types, that is if I'm using the decimal values, I'm using the integer type. That is a bad type. Why? If I'm using 0.5, that can be accessible with the float data type, not the integer data type. Then leaks, that is a runtime exception. That is these are the error that is available at the runtime. Then next is your interface errors, that is the interface error between the modules. That is threads, program, that is any error or any error that is placed between the interaction. That is if there is a communication between the modules, if there is a communication between the threads, that is a interface error. In particular with shared resources, sockets, files, memory, etc. So interface error means the communication errors that is used is the interface error that occurred between the modules, that occurred between the threads, that occurred between the programs. That is also a part of the runtime exception. Then next is your off nominal conditions. Next type of error is that, or next type of bug is that off nominal condition. That is failure of some part of software of underlying machinery. That is my network is failed. Suppose I'm taking the best example. Suppose I'm taking your class. Currently my network has gone, my internet has gone. So this live object, this live training will be diminished or will be stopped. Why? There is a bug, there is an error in the any programming language, if there is any error in the networking. So that is also a type of error, that is the off nominal condition. That is this is a condition that nothing is in my hand. Why nothing? Because there is a low bandwidth, because there is a cyclone that is going on in my country, there is an earthquake that is going on in my country. That is also a nominal condition of nominal condition, that is usage. That is a network breakdown, the best example, and this gives the incomplete functionality. Next is your deadlocks. That is the next type of bug, that is a deadlock. This says multiple processes fighting for a resource. That is more than one process or the multiple processes fighting for a process. Fight for different processes that is executing, or fight for a resource that is using the various processes. That is one resource is used by various processes, that is a deadlock. So deadlock is a condition in which neither we go afterwards or neither we go beforewards. That is, it is the stoppage area. The best example is that the train. If two trains collide with each other, so neither train go backwards or neither train goes forward. So that is the condition of the deadlock, and this is also the type of bugs. That is multiple processes fighting for a resource. That is a deadlock condition. Now, what are the output, or what is the output that is generated after the deadlock? That is a freeze up, never-ending process. So this is a freeze up and the never-ending process. The ideal debugging process, that is the this is the ideal debugging process that is using the or that is avoiding the debugging process, or that is avoiding the bugs that is available in the program. A debugging algorithm for software engineering. First of all, it identifies the test cases that reliably show existence of the fault. That is, first of all, identify the test cases that what are the test cases that is used that shows the existence of the faults whenever the fault is available or whenever possible. Then isolate the problem to the small fragment of a program. Isolate problem means differentiate the problems to the small fragments, to the small parts of a program. Next part is correlate incorrect behavior with the program logic or the code error. That is also ideal debugging process. That is, correlate the incorrect behavior with the program logic or the program code. Or we can also change the program, that is, check for other part of the program where same or similar program logic may also occur. Also, the debugging process uses the regression testing. There are two types of testing that is available. One is alpha testing, one is regression testing. Alpha testing is done before when we implement the software at the user side. That is, this is the problem, or this is the testing that is done before the system is set up. And the regression testing is verified or occurred or is used whenever the system has been set up. So that is, one is used before the system has set up, one is used after the system has set up. And regression testing is used as a debugging technique to verify that the errors has really been removed without inserting the new errors. Then update the documentation when required, appropriate. That is also the ideal debugging process. Not all these steps need to be done by the same person. Now, what are the general advice? Try to understand as much of what is happening as possible. That is, try to understand that things that is required. It also compiles, that is, it compiles is not the same as it works. That is, if I'm saying it compile, that is not the same as it works, because compilation does not give sometime error or gives sometimes error. So that is not same as at its works, because if there is any error, that is also available at the compile time. If I'm saying it works, that is totally different from it compiles. When it doubles, ask, then test the answers. Error messages are generally just a vague hint and can be misleading. So error messages are generally a huge hint and can be misleading or can be misled by using the general advice. Don't always trust the commands, documents, they can be out of date. So cannot trust on the, or cannot don't trust on the comments or the documents, because they can be or they may be out of the date. Now, what is a debugger? A software tool that is used to detect the source of the program or the script errors by performing step-by-step execution of application code and viewing the content of code variable. So if I say debugger, Debugger, in simple terms, debugger is a tool technique that is used to find the bugs in the program. This says debugger is a software tool that is used to detect the source of the program or script errors. Detect the source of the program means detecting the program errors or the script errors by performing step-by-step execution or by performing the detailed execution of the application code and viewing the content of the code variable. So in simple terms, debugger is used to find the bugs in the program. A debugger is not an IDE. Why? Because it is not the integrated development environment. That is not an IDE, but it is a tool or the technique that is used to find the bugs in the program. There are, though the two can be integrated, they are separate entities. That is, debugger and IDE are used interchangeably, but these are those two different entities. A debugger loads in a program and allows the user to trace through the execution. As I told you, it is a technique that is used to debug the error, that is used to provide the error. So debugger loads in a program, loads in any program that is a compiled executable or interpreted source code and allows the user to trace through the execution. Trace means finds the error through the execution. Next says debugger typically can do disassembly, stack traces, expression watches and much more. That is a debugger. Next question arises why we are using the debugger. That is, what is the use or what is the advantages why we are using the debugger. That is, no need for precognition of what the error might be. That is, there is a need for identifying the error. That's why we use the debugger for finding the error, for finding the bugs in the program. Then flexible. Flexible means what is the flexibility in the debugging? That is, it provides the facility or it provides the flexibility in showing the errors, in updating the errors. It allows for the live error checking. Live error checking means suppose I'm writing the C program. So debugger also provides the facility. At the same time when I'm writing the program, the error will be removed or error will be debugged from the program. That is, it allows for live error checking. That is, no need to rewrite and recompile when you realize a certain type of error may be occurring. So there is no need to rewritation or there is no need to rewrite and recompile the same code again and again when you realize a certain type of error may be occurring. Why? Because the error is occurring at the live or the live approach only, that is the live error checking. Then next is your dynamic. Debugger also provides a facility to dynamically allocates the or dynamically uses the memory. Then next point says can view the entire relevant scope. That is, it can view the entire relevant scope. That is also advantage or uses of debugging or debugger. That is, it can view the entire relevant scope. Then why people don't use a debugger? Because the main reason is that with simple errors may not want to bother with the starting up the debugger environment. Obvious error, simple to check using the print and the assert. So why the main reason is that why people do not use a debugger, because the simple error can be removed without the debugging or without using the debugger also. It is hard to use debugger environment. So it is very hard to use the debugger environment because that is a automated system, that is an online system, the internet is required, and there are also the wizards or the template that is available for using the debugging techniques. So this is also an application or the technique that is a online technique or the online application. Then next is error occur in optimized course. That's why people do not use a debugger. then changes the execution of the program. Then also it also, or debugger also changes the execution of the program, that is the error that does not occur while running the debugger. These are the debugging techniques. Now let's see with the help of book. The next category of error is that reading uninitialized memory. This says while BSS memory locations are always initialized to 0 by the loader, this is not true for the heap memory. That is, while BSS or the BSS memory locations such as uninitialized global C variables are always initialized to 0. That is, whenever we use the uninitialized global variable, they are initialized to 0 by the loader. That is not true for the heap memory, that is not used by the heap memory. A common error is that we can assume that heap memory is initialized to 0. So reading the uninitialized memory, that is the best, or that is the main error that is used. That is not that is an error that is used for the heap memory, that is initialized to 0. That is the error. This says return y2 equals to ax. There is a int, then there is a asterisk, that is a mat vec that is used, int pointer a, int x, int n. Then uses the curly braces int ij. That is, these are the argument that is used. One is using the pointer, double pointer, that is pointer to the pointer, and there is a simple variable that is of integer type. Then there is a int ij, that is two variables are declared, that is of I and that is of j. Then one pointer variable is used, that is int pointer y, that stores the address of some another variable, that stores the output of the malloc function, that is allocating the memory and gives the size, and that size or that address location is stored or is available in the pointer variable, that is the y. So y is a pointer variable that is of integer type. So this is the next bug that you use, that is reading the uninitialized memory. My system is hang up. Yeah, this is working. For I equals to 0, I is less than n, I plus plus. Then next loop is that this is the inner loop, that is j equals to 0, j is less than n, j plus plus. This is the outer loop, this is the inner loop. Then y I plus equals to ij into xj. So first of all, uses the matrix that is at the 0 0 location, then as 0 1 1 0 till the n condition is that n is the number that is available from the user into xj. So one time it is x0, x1, x2, x3, so then returning the value that is return y. In this example, the programmer has incorrectly assumed that vector y has been initialized to 0. A correct implementation would explicitly 0 yi or use the calloc function. So this is the next bug, that is heap memory is initialized to 0. The next bug is that the third type of bug is that allows stack buffer overflow. So if there is a stack buffer overflow, that also a bugs of the bugs in the C programming language. That is also error in the C programming language. A program has a buffer overflow bug if it writes to a target buffer on the stack without examining the size of the input string. So this says a program has a buffer overflow. If I say the program or the any syntax or the code has a buffer overflow bug if it writes to the target buffer on the stack without examining the size of the input string. That is the best, that is the target buffer that is used, that is used on the stack or target buffer on the stack without examining the size of the input string. For example, the following function has a buffer overflow bug because the gets function copies an arbitrary length string to the buffer. To fix this condition, we will need to use the fget function, which limits the size of the input string. So if a program has a buffer overflow, that also gives an error. So if a program has a buffer overflow bug, if it write to a target buffer on the stack without examining the size of the input string. To fix this error, we use the fgets function. Before that, we are using the gets function. Now I'm using the fgets function, which limits the size of the input string. Now let's see the syntax that is used. One is void buffer overflow. Then char buffer 64, that is using the array variable that is of type buffer that has a 64 numbers. Then gets buffer, here is the stack buffer overflow bug. This is the stack overflow bug, that is buffer is of 64, there is an overflow, that is gets cannot access the variable, that is the gets cannot use the variable. Instead we are using the fgets function that limits the size of the input string. This says because the gets function copies an arbitrary length string to the buffer. That is the main reason that there is an overflow of the buffer. So the solution is that use the fgets function. Next, assuming that pointers and object they point to are of same size. This is also an error of the C programmers, that they assume that pointer and the object they point to. A pointer means that stores the address of another pointer, and the object that point to another area are of the same size. That is the one common mistake, is to assume that pointer to objects are the same size as the object they point to. For example, this is the example, that is int pointer pointer make array int n int m, that is int I int pointer a, that is using the function, that is the name of the function is make the array, and the argument is using two variable, that is n and the m. Then uses the variable, that is int I int pointer pointer a, and stores the malloc function on uses the malloc function and store the output, that is using the malloc function, and store the result in the pointer pointer a. Then uses the for function, that is for I equals to 0, I is less than n, I plus plus. Then using the array variable, that is using the malloc function. So this is the bug that is used, that we assume that, or the programmer assume that pointer and the object they point to are of same size, but that is not true. The intent here is to create an array of n pointers, each of which points to an array of m ints. However, because the programmer has written size of int instead of size of int pointer in line 5, the code actually creates an array of ints. Next is making off by one error. That is the next error, that is making off by one error. Before starting with this error, now let's take a break, that is 5 to 10 minutes break, and then come back starting with this error, that is the next error, that is making off by one error. So let's take 5 to 10 minutes break and then come back. Now let's start with the next bug, that is the next error that is used, that is the making off by one error. So this is the next type of error, the 4 error that we have studied, already studied. Now the next error is making off by one error. This is off by one errors are the another common source of overwriting the bugs. So this is also a category of overwriting the bugs, that is how to overwrite or how to overwrite the bugs by using the off by one error. The same example is used. Make array 2, so this is the function that is used, that is the function name is make array 2, and these are the two arguments, one is m, one is m. there is a int I, that is a int is a variable that is of int I is a variable that is of integer type that takes 2 bytes. Then there is a pointer variable that is int pointer pointer a, that is a is a pointer to the pointer. Then int pointer pointer malloc, that is malloc is used for allocating the value, and the output is stored in the a variable that is also of int type. So that is a off by one error, that is a overwriting the bugs, that is we can overwrite the bugs into the one place. Then next is your next part is your you using the for loop, that is for I equals to 0, I is less than n, I plus plus. In the same way it will start from the 0 and it will end till the n values, that is the n, that is the int n. Then ai equals to int pointer malloc m into size of int. So this is the size of int that gives the size of the integer value that takes 2 bytes, that is allocating by using the malloc function. Then use the int pointer variable, that output will be stored in the ai. How it will stored in the ai? First of all, it goes to the a0 location, then a1 location, a2 location till a9n location, that is given by the user. This is another version of the program in the previous section. Here we have created an n elements array of pointers in line 5. This is the n array elements of pointer. This is the int pointer pointer malloc. But then try to initialize n plus 1 of its element in lines 7 and 8. This is the 7 and 8 line, that is using the for loop, in the process overwriting some memory that follows the a array. Now next part is referencing a pointer instead of the object it points to. This says if we are not careful about the precedent associativity of C operator, then we incorrectly manipulate a pointer instead of the object, or instead of the object it points to. So in simple terms, when we are writing the C program, we can reference a pointer in a wrong condition, we can reference a pointer in a wrong way. It treats as the object that it points to. So if you are not careful about the associativity, precedent associativity of the C programming language of the pointers, then we incorrectly manipulate a pointer instead of the point it points to. The best example is that if I'm using or remove the first item in the binary heap of pointer size items, and then reheaply the remaining pointer size minus 1 items. That is using the variable, using the function that is int binary heap delete. So this is the function that is used. Int is of int is a return type, that returns the type, or this is the return type of this function. Then use the int pointer pointer bin heap int pointer size. So these are the two arguments that is used. One is using the pointer to the pointer of the binary heap, one is the pointer to the integer value, that is a integer value of the size. Then int pointer packet, that is using the pointer variable packet that stores the output, or that stores the first element of the binary heap, that is at the 0 location. Then uses the binary heap 0, that is 0 location, or the first location is given, or it stored the output of the binary heap, that is size minus 1. Then decrement the size, that is size minus minus. Then use the heap i5, that is the binary heap pointer size 0, then returns the packet. This is the error, or this is the bug that is used, that is referencing a pointer instead of the point it points to, instead of the object it points to. In line 6, the intent is to decrement the integer value. This is decrementing the integer value pointed by the size pointer. However, because the unary minus minus and the pointer operator have the same precedent and associate from the left to the right or the right to the left, the code in line 6 actually decrement the pointer. So this is the best example why we are using the reference pointer, why we there is a difference, or there is a problem with the associativity whenever we use or we reference a pointer. The code in line 6 actually decrements a pointer. This actually decrements the pointer variable itself instead of the integer value that it points to. So sorry. So it decrements the pointer itself instead of the integer value that it points to. If you are lucky, then the program will crash immediately. Means if you are lucky, then the program gives the out error immediately. Otherwise, it gives the error after implementing or after recording or keying all the coding commands. The program will crash immediately, but more likely we will left scratching our heads when the program produces an incorrect answer much later in its execution. So it's better to for the program to crash immediately if there is a wrong input or the wrong output. Instead, I'm writing each and every lines of the instructions, every code, and then at last the program will gives an incorrect answer, incorrect output. That's not good, because we cannot, or we are not able to detect the errors in the beginning. That's the main reason. So use the or crash the program immediately if it is better one. Next error is that, next bug is that misunderstanding the pointer arithmetic. That is the next type of bug that is available. That is another common mistake is to forget that arithmetic operations on pointer are performed in units. That is another mistake, is to forget that arithmetic operations on pointer are performed in units that are size of the object they point to, which are not necessary bytes. This is the mistake that we generally as a user, as a programmer, we forgot that arithmetic operations on the programmer like plus, minus, divide, multiply, that is addition, subtraction, division, multiplication, are performed on the units or are performed in units that are the size of the objects they point to, which are not in bytes. For example, the intent of the following function is to scan an array of ints and return a pointer to the first occurrence of the val. So using the variable, using the function that is the int pointer search, then uses the two arguments, uses the argument that is that are of two types. One is int pointer p, that is pointing the that is using the pointer p, then int val, that is using the val variable. Then use the while condition, that is it is running while pointer p and the pointer p not equals to null. That is using the AND condition, that is if both the condition are true, then only the output will be displayed, otherwise the output will not be displayed. This says while pointer p and the pointer p is not equals to the val, that is not equals to the val variable, the output of the val variable, then p plus equals to size of int, that is using the variable that is p, incrementing the value and store the output, that is the size of int, that is the integer value output will be stored in the p variable, then return p, then return the value, that is the p. So this is the misunderstanding of the pointer variable, that is it should be p plus plus. Why p plus plus? Because there are two values that is used. P plus plus means incrementing the value. This is p plus. This is the misunderstanding the pointer arithmetic. However, because line 4 increments the pointer by 4, the number of bytes is an integer. Why it is incrementing the values by 4? Because integer takes 2 bytes and it is of 2 values, or it contains 2 values, so this is of 4 bytes. Each time through the loop, the function incorrectly scan every fourth integer in the array. Why it every time it scans wrong? Because this is using the p plus, not using the p plus plus plus. That's the main reason. This is the main or the more critical error or the more critical bug that is available in any C programming language, that is related to the memory conditions. And the next category of the pointer arithmetic is that in the same way, if I'm using p minus minus, here if it is p plus equals to size of int, in the same way next arithmetic that is used is either p minus p multiplied, that is multiplication, p division. Now let's see p minus. This is the same example, int search, that is searching the values related on based on the pointer p on based on the val variable. Then uses the while condition, that this condition or this output will display until this condition is true, that is pointer p and the pointer p is not equals to val. Then stores the output of the int variable to the p variable. If I'm using p minus equals to size of int, the same output or the same error will be displayed. Why? I'm using only single plus or single minus in a subtraction case. But if I'm using or if I'm able to write, or if I want to write the correct program, then I must write p minus minus. Why? Because it is decremented twice, because it is taking the values twice, that is 4 bytes, so it will be p minus minus. However, the same line is followed. Next bug is you are referencing non-existent variable. That is how to reference a non-existent variable that is not exist. Sometimes the programmers, the C programmers who do not have an understanding of the stack pointer will sometimes refer the local variable that are not longer or that are no longer valid in the following example. So they may use the non-existent variable that is not exist. They can reference or they can refer that variables. This is the pointer, or this is the syntax that is used. This is the example, that is int pointer stack ref, that is using the pointer variable that is a stack ref, that is a stack reference. Then uses the variables, that is the int val, return ampersand val. So these are the two variables that is used. One is a one is a simple variable, that is of val variable, that is of type int. One is of return type, that is a ampersand val, that stores the output or that stores the address of the val variable. This says this function returns a pointer, say p, to a local variable. So it returns a pointer to a local variable on the stack and pops its stack frame, although p still points to a valid memory address. P still means p till now it stands for a valid memory address if it is no longer points to a valid variable. When other functions are still or called later in the program, the memory will be reused for their stack frames. Later, if the program assigns some values to pointer p, then it might actually be modifying and entering another function stack frame with potentially destructive and battling consequences. So this paragraph says if I'm using the local variable on the stack, then it's point to the stack frame, although the p still points to the valid memory address and it no longer needed by the valid variable. Later, if the program assigns some new variable to the pointer p, then it must be modifying, or it should be modifying and entering the function stack frame with the main differences with the major differences. So this is the error, that is sometimes the programmer refers the non-existent values, non-existent variable, that is the variables are not exist, but the programmer refer that variable. So that is the main error, that is the main bug that is available in any C programming language. Next is referencing the data in free data heap. That is next category is that reference the data, that is reference the data in the free data heap. A simple error is to reference the data in the heap block that have already been freed. That is I can refer the data in a memory that is already free. If I refer, that is also error, or that is also a bug in any C programming language. This is a simple error, or a common error is to reference the data in the heap blocks. Heap blocks means virtual memory that uses a heap, that is in heap block that have already been freed. That is if the mark, suppose I am using the mark and sweep algorithm. The sweep algorithm already freed the cells, right? And if I am using that freed cell again for the data variable, so it can reference the data, or it can uses the data in the free block, that gives an error. For example, Consider the following example which allocates an integer array x in line 6. Prematurely free block x in line 10 and then later reference in line 14. That is, in line 6 it is used, then it is freed in the line 10 and then again it is used in line 14. That gives an error. Why? Once it is freed, that is destroyed, that is not again used, but again it is used by line 14, that is also an error. This is int pointer heap reference, that is the name of the function. Two arguments are used, one is n, one is m, and both are of integer type. Then one is int I, that is using the variable that is of integer type, that is int I, then using two pointers, that is int pointer x and int pointer y. Then uses the x variable, stores the output using the malloc function, that is int pointer malloc n into size of int. This is the example of the malloc function, that is the size will be allocated in the form of int by using the size of operator, and that output will be stored in the x. Then this says this is the comment that says other calls to malloc and free go here. Now free x. Now first of all, the x will be allocated, the x will be occupied, that is allocate an integer array. When in 10th line it frees the block by using any algorithm, by using the mark and sweep, by using the any algorithm that is used for free the memory or freeing the memory. Then again in 13th line or in 12th line it is using y equals to int pointer malloc m into size of int. Again using the for variable, that is I equals to 0, I is less than m. Then uses the array, that is yi equals to xi plus plus, then return y. So in again 14th line it is used as a variable, that is again using the x variable. This says oops, xi is a word in a free block. So this is how this is the major bug or the critical bug that is used, that is we can refer the same object that is already freed by the programmer, that is already freed by any algorithm, that is either mark and sweep or any algorithm. In simple terms, it is freed by the programmer. So depending on the pattern of malloc and free calls that occur between line 6 and 10, when the program references xi in line 14, the array x might be a part of some other allocated heap block and have been overwritten. As with many memory related bugs, the error will only become evident later in the program when we notice that the value in y are corrupted. Then next error is that introducing the memory leaks. This is the next error, that is introduce the memory leaks. This says memory leaks are slow, silent killer that occurs when the programmer inadvertently create garbage in the heap by forgetting to free allocated block. This says whenever we introduce the memory leaks, that is a silent killer. Silent killer means that does not impact our program, but they are the silent killers that kill our program, that occurs when the program or when the programmer inadvertently create the garbage in the heap by forgetting to free allocated blocks. That is, it creates an memory leaks whenever programmer creates an bugs or creates an garbage by forgetting to free the allocated block. Suppose I am writing the C program, the best example I have taken of myself. Suppose I have written the C program, right, or I am writing C program. The one function that is used is no longer required, that is calculation function is no longer required, but still now the function is available in my program, that is I cannot use the garbage collection to free the allocated block. That gives an error, that gives an bug, or that is the main bug, that is introducing the memory leak. For example, the following function allocates a heap block x and then return without freeing it. That is, it returns a value, it returns the heap block, that is x block, and then returns without freeing it, without releasing it. is the example that is used. So this is the example of the memory leak. That is the example. The example starts with the leak function. That is a leak function that has a return type of void, and one argument is used, that is int n. Then int pointer x, that is using the pointer variable, that is pointer x. That is using the pointer variable that stores the output, that is int pointer malloc n into size of int. That is first of all uses the size of variable that is of integer type, uses the malloc function for allocating the memory, and stores the output in the pointer variable that is a pointer x, then returns the values. This is x is the garbage at this point. That is x is garbage means x is the garbage or x become garbage at this point. Then next says, or the next paragraph says, if leak is called frequently, that is if the leak is frequent, or if a leak is called on a frequent basis, then the heap will gradually fill up with garbage. That is, if leak is called frequently, that there is a leak in every 5 minutes, 5 nanoseconds, then the heap will gradually fill up with the garbage automatically. Whenever there is a more garbage, whenever there is a more leak, so there is a more garbage collection that is collected with the garbage. In the worst case, consuming the entire virtual address space. Memory leaks are particularly serious for programs such as daemons and servers, which by definition never terminates. So this is the impact why we are not supposed to use the memory leaks that impacts the programmers, or that impacts the programs. Now, next is your summary part. That is the summary. That is the summary of the chapter. So now, good. This chapter is finished. So this is the last topic that is covered in the today's class. That is the memory-related bugs in the C program. This says virtual memory is an abstraction of the main memory. Processors that support virtual memory reference main memory using a form of interaction known as the virtual addressing. The processor generates a virtual address which is translated into a physical address before being sent to the main memory. The translation of addresses from a virtual address, physical address requires close cooperation. So this is the a summary that we have covered, what we have covered in the this chapter. First of all, there is a virtual memory. That is the definition of the virtual memory. What is the difference between the virtual address space and the physical address space? And also the virtual memory provides three main important capabilities. That is, it automatically caches the blocks, it automatically caches the use instructions. Then we have also studied about the memory mapping. That is, the process of address translation must be integrated with the operation of the any hardware caches in the system. Then next, modern system initializes the chunk of virtual memory by associating them with the chunk of files on the disk. That is known as the memory mapping. So in simple terms, the memory mapping is that initialize the chunks of the virtual memory by associating them with the chunk of file on the disk. That is known as the memory mapping. That provides an efficient mechanism for sharing the data, for creating the new processes, and for loading the programs. That is done by the mmap function that we have studied. Then we also studied about the malloc function. Then this says allocators comes in two flavors. That is, one is your explicit allocators, one is your implicit allocators. Explicit allocators are the allocators that explicitly allocates the memory, that explicitly free their memory blocks, and implicit allocator that is done by the garbage collector, free any unused memory or free any unused and unreachable blocks automatically. So in explicit allocators that is done in manual way, and in implicit allocator that is done in automatic way. Then Managing and using the memory is a difficult, error-prone for C programs. Example includes bad pointer that we have studied in the today's class. So these are the topics, these are the summary of this topic or this chapter. Now next is your bibliographic notes. These are your homework assignments. These are the solution to the practice problem. These are the solutions of the problem that is covered in this book. These are the various solutions to the problems. This is the solution number problem number 10. Now next is your system level input output. That is the how system level input output operation is performed. That is the next chapter that I've started or I'm starting the in the next class. That is the system level input output. So this chapter I'm starting with in the next class. Yeah, one important thing is that the next class will be on the Monday. That is, there is no class for tomorrow because tomorrow I have some urgent work. So there is no class for tomorrow. Now class will be on the Monday. That is on 3rd of November, right? Tomorrow is the Friday, and I'm on leave on Friday, and the Saturday Sunday there is no class for Saturday Sunday. So directly there is class on Monday only. So let's take a quick review what we have covered in the today's class. So that's all for today's session, but let's take a quick review. We have started with the topic that is the common memory related bugs in the C program. So first of all, we have studied what is a bug, that is an error, and memory related bugs means that is generally or the error that is related to the memory or that is stored in the memory. That is memory related bugs, and these are the common memory related bugs that is available in any C programming language, any C program. This says managing and using virtual memory can be a difficult and the error-prone task for the C programmers. Memory-related bugs are among the most frightening because they often manifest themselves at a distance in both the time and the space. So we have studied about the management. We have studied why there is a limitation, there is a more space requirement, there is a more time requirement. So that is a memory related bugs. Then we have studied about the types of the bugs that is available in any C programming language. One of the bugs that is available is dereferencing the bad pointers. This is again the bug, this is again the error. That is we are or the programmer or the C programmer dereference or you reference the bad pointer, that is it is using or he or she is using the bad pointer, that it is refers to the next variable. Then reading the uninitialized memory. This is again the next bug, that is the next bug is that read the uninitialized memory, that is reading the memory that is not initialized. That is also a bug that is generally used by the or generally done by the programmers. Then we have studied about the programming code of the C language. The next bug that we have studied is allowing stack buffer overflow. Sometimes the bug also occur in a stack buffer overflow. That is there is a overflow of the stack. That is the stack elements are going more upper. That is the overflow of the buffer overflow bug. That is the buffer on the stack without examining the size of the input string. Then next is that assume that pointer and the object they point to are the same. So sometimes the C programmer have a tendency to assume that the pointer that is using and the object they point to the pointer are the same one, are of the same side. But no, that is a main bug. That is a bug that is related to the memory. That is a memory related bugs. Then next is making off by one error. So this is the next bug, this is the next error, that is how to make the off by one error. Then we also studied about how to reference a pointer instead of the point it points to. This is also an error this is the error that is known as the referencing a pointer, that is the programmer reference a pointer instead of the object it points to. Next is misunderstanding the pointer arithmetic. This is one of the critical bug, that is in the mind of C programmer there is a misunderstanding of the pointer arithmetic, that is plus, minus, addition, subtraction, division, multiplication. The next bug is referencing the non-existent or non-existent variable, that is sometimes the programmer also refers the non-existent variable that does not exist in the memory, that does not exist in the program. So this is also a bug error. Then next error is that referencing the data in the free heap block, that is sometimes the programmer also refers the data in the free block, that is it can refer the data in the free block, that is using the free block memory. And then at last we have studied about the introducing the memory leak, that is also the limitation, that is introduce the memory leak that is available. That is sometimes that there is a leakage and that leakage stores the or that leakage makes the garbage in the worst cases. Then we have studied about the summary. That is what we have covered in the today's topic or in this chapter. So that's all for today's session. Now if you have any doubt, then please text the doubt and I will answer you. And for Larry, this is for you. I will show you or I will tell you how to use the manual or how to use the book that is studied by you. So that's all for today's session. Now the next class will be on Monday and the next topic is system level input output. That is I think that is the last topic of this module. I'm not sure. Yeah, that is the last topic. So that's all for today's session. Thank you so much everyone. Now still if you have any doubts, then please text the doubts.